Hello grade 11s, in this video I am going to work through question 1 of the mock exam, and I will do another video where we will work through question 2. So in the previous video we went and looked at all the different pieces of information given. So in this video I'm going to quickly work through how to get the answers. So 1.1, the first question says determine the values of K and P, and we said we need to use the midpoint B to work out our coordinates for F. Just a reminder, the midpoint formula is the sum of the x values divided by 2, which will give us the x coordinate of our point B, and so that'll be K plus -4, K coming from point F and -4 coming from point A, all divided by 2. And we will do exactly the same thing with our y values. So our y value for point B is -2 is equal to point K's y value is P plus point A's y value, which is 1, and we divide that by 2. And to solve for our variable, we do exactly the same steps. So both sides will be multiplied by 2. So that will give me -2 is equal to K minus 4. And then I will add 4 to both sides, leaving me with 2 is equal to K. And then I go to my y values. I multiply both sides by 2, giving me -4 is equal to P plus 1. I subtract 1 from both sides, leaving me with -5 is equal to P. And I double check. Yes, I've answered the question. I have the value of P and K. Now, before I carry on, I will go to my question paper and write in my K and my P value in case I need them later on. And don't forget this one up here that we highlighted to make sure that we don't forget. 1.1.2, we need the gradient of AF, and we have 3 different points that we can use. I'm going to use point A and point F. So gradient is represented by a small m, and it is the change in y over the change in x. So I'm going to put the y value over its corresponding x value in a point. So there you can read point A, and then I need my change and I need my y values. So I'm going to put my y value, -5, whoops, that's a terrible 5, over my x value, which is 2. And I plug that into my calculator, and I get an answer of -1. And that is my gradient of AF. 1.1.3, we need to determine the equation of the perpendicular bisector of AF. And as we said before, if we've already got the gradient of AF, we can use the idea of being perpendicular to work out the gradient of our new line. So let's do that part first. 1.1.3, we know that gradient 1 times gradient 2 is equal to -1, and our gradient 1 is -1, and m squared minus 1. And this is a really easy one because they haven't given us a fraction. We divide both sides by -1, giving me an m2 is equal to 1. But that's only the gradient of our line. And what you can do is you can substitute it in so long. So y minus y1 is equal to the gradient times gradient. Instead of gradient, I'm going to write 1, x minus x1. Please try not to write over other numbers. Rather cross out a mistake and write the number above it. Then we need a point. Now, the other part of the name of this line, perpendicular bisector, is bisector, which means it cuts in half. And so if we go here to line AF, point B cuts that line in half. And so we've got our point that we can substitute in. So the y value for B is -2, which I will put into brackets, times by 1, and my x value for point B is -1. And now we solve for y, and this is the easy part. Y plus 2 is equal to x plus 1, and I subtract 2 from both sides, leaving me with x minus 1 as the equation of my line. 1.2, determine whether triangle CAF is equilateral, isosceles, or scalene. And we said we're going to use the distance formula to work out the length of the line. And so let's start with line AF. So 1.2, we've got line AF. Now don't forget your distance formula is the x values being squared plus the y values being squared, or being square rooted. So the x value for point A is -4, and the y value is 1, and we want the distance between these 2 points, so we're going to subtract. And then point F, our x value is 2, and our y value is -5. And you put that into your calculator, and you should get 6√2. You can write down the decimal value for this, but I would stick to a surd, which is more accurate since they're not asking for the actual answer. Right, I'm not going to explain to you how to substitute in to work out the length of AC. You can do that on your own, and how to work out the length of FC. I will fast forward so that you can see the final substitution. There we go. Now we know the lengths of all 3 sides, and we can see that there are no sides that are equal. Therefore, triangle CAF is scalene. And if you are struggling to spell it, just go look in the question paper. Usually they'll have the answer right there for you to copy. 1.3, determine the value of theta and hence of angle AFC. Now, I'll ignore that part and I'll focus on the theta part. And as I said before, we're going to use our tan theta is equal to m, but I need to look at my line. Is it a positive line where it's immediately going to be theta, or is it negative where I'm going to use a different variable for theta? So finding it on my picture, here we have theta, and it is the inclination of this line. Now we know from 1.1.2 it has a negative gradient, so we're going to have to use a variable instead of theta. So I'm going to use beta. Tan of beta is equal to my gradient, which is -1 from 1.1.2. And we want beta on its own, so I'm going to put tan inverse 1 into my calculator of -1. And don't forget to use your brackets then. So on your calculator, just a reminder, we have tan over here. So to get our tan to the -1, we're going to go shift, tan, -1 inside, push equals, and we get -45. So beta is equal to -45 degrees. So to get to theta, we're going to have to add 180 degrees onto that, because this is going in the wrong direction because it's a negative angle. So I add 180 degrees, which gives me 135 degrees. Now that I have theta, I will go and look at the rest of the question, because the hence tells me I need to use this anyway. So I might as well wait until I've got that value before I try and work out the size of angle AFC. So here we have angle AFC, and it's difficult to see if there is a relationship between those two. They're on the same line, but there are no parallel lines or anything to connect them. But we know that this side of the angle CF is 90 degrees to my x-axis because it is parallel to my y-axis. So we can bring in a parallel line to CF in over here that is 90 degrees. And remember your parallel lines for grade 8. If we look here, we've got our F shape, and so this angle and this angle are corresponding angles, so they are the same side. So if I work out this angle, I know this angle. And what we see here is we've got an extra 90 degrees on the other side of the line, part of the bigger angle. And so if we say theta minus 90 degrees, we will get this little part on that side. And so your calculation will look like this. Don't forget to label your angles so that they know what you're calculating. Angle ACF is going to be theta, 135 degrees minus 90 degrees, which gives me 45 degrees. So it might look like a simple calculation, but the thinking to get to that calculation is quite complex. And as you can see, as we get further down along this question, our questions are becoming more and more complex. Right, question 1.4. Explain why the perpendicular bisector of AF cannot pass through C. Now, let's think about when will the perpendicular bisector pass through point C. So if I have a triangle like that, I cut these two sides in half and I bring a line there at 90 degrees. Do you agree that will be my height? Now the only time I get a height 90 degrees and those two cut in half is when we have an isosceles triangle. Now it also works in an equilateral triangle because it is more specific than an isosceles triangle. So for the perpendicular bisector to go through point C, this triangle has to be an isosceles triangle. So going back to the question, explain why the perpendicular bisector of AF cannot pass through C. We would say if BC were the perpendicular bisector, then triangle CAF needs to be what kind of triangle? Yes, isosceles. And if you're not sure how to spell it, go back to 1.2 where they've given you the spelling for it. There we go, 1.4. Now for our final question, 1.5. Now because this is the last question, it's either going to be a complex question or a problem-solving question. If point D is a point on CF such that BD is parallel to AC, determine the value of Y. So we kind of played around and we kept our two lines parallel to each other. I drew in a line and I made us a point D over there. Now, they haven't asked for us to explain how we get this point, but if you notice, B bisects this line in half, and those two lines are parallel, which means we're working with our midpoint theorem from grade 10. And that is why this is at the end, because it's taking concepts from another topic and bringing it into analytical geometry. So because those are equal and those are parallel, we also know that this is going to be equal to that, which means D is halfway between those 2 points. Now C is 5 up and F is 5 down, so halfway would actually be on the x-axis where I accidentally drew this. And so going back to the question, it asks us to determine the value of Y. Our Y value is 0. And so 1.5, Y is equal to 0. Now I wouldn't spend too much time on this problem because if you notice, it's only 2 marks. So I would spend 2 minutes on it. If I'm not seeing anything obvious, I would carry on with the rest of my paper. And if I have time, I would come back to it. Don't forget at the end of your question to draw a line so that we know that you are finished with that question.